This is the video to help you prepare for the Chapter 4 material on the semester exam. So this first problem is a word problem where you're supposed to write a linear model. That's just another way of saying you're going to write a linear equation in slope-intercept form. So y equals mx plus b. And so this particular scenario is talking about a new machine that is, the word is depreciating, and that's just another way of saying it is going down, it's declining in value. So you can think of this as when you're thinking of the line that's represented by this equation, it's going to be a line with a negative slope, because over time the machine cost $180,000 when it was new, but over time its value decreased because of age and usage. So what we have to do is find out how much is it decreasing per year, and that's what this straight line method is referring to. So you basically just take the total cost and divide it by the number of years that it's going to be depreciated, and that will be how much it depreciates per year. And the amount of depreciation is going to be what we're going to put in for slope, but again, it's going to have to be a negative number, because this should show a decrease in value over time. All right, so instead of y, they want to do v for value, and the slope is going to be negative 18,000. And b represents how much the machine cost when it was new. What did it start out as in its value? It started off being worth $180,000. So there is the answer for letter A. Letter B, the implied domain, they don't really tell us what to put in for x, but we know that it's not going to be depreciated for more than 10 years. And you wouldn't depreciate for negative years, of course. So we could state the implied domain as all the numbers between 0 and 10, representing the number of years. Could be no years, that's when it's new, up to a maximum of 10 years. And then letter C, the book value of the machine after 4 years, so we just put 4 in for x. Multiply 4 times negative 18,000, and that should be negative 72,000. And then we're just going to add that to the original cost of 180,000, and that's $108,000. So that would be your answer for letter C. And then for letter D, when will the machine have a book value of 72,000? Well, V stands for book value, so we could just put 72,000 in for V into this equation and solve for x. All right, so I would subtract 180,000, and that should be negative 108,000. All right, so I'm just solving for x, so I'll just divide that by negative 18,000, and that is 6 years. So x equals 6, so after 6 years, it's worth, that's another way of saying book value, it is worth 72,000. All right, so that's the complete answer for number 1. And then on numbers 2 and 3, you're being asked to graph quadratic functions, come up with these parabolas. So we'll just go down the letters as they're given. Determining whether the graph opens up or down and finding its vertex. Well, number 2 opens up, And it's already in vertex form, which is nice. So the vertex will be -3, -2. And since we got to graph it anyway, we'll just go ahead and plot this information as we collect it. So there's the vertex. Let's see, the AOS is the line, the vertical line that goes right through the vertex. And so that's going to be the line x equals -3. The y-intercept, can't really see the y-intercept in vertex form, but if we want the y-intercept anytime, we can just let 0 replace x and simplify. So if we let x be 0, that's 3 squared, which is 9, minus 2, so the y-intercept is 7. The x-intercepts will be found by solving the quadratic formula if it's in standard form, but since it's already in vertex form, we'll just let y be 0 and solve for x. All right, so we would add 2 to both sides. We do the square root of both sides. And then we would subtract 3 from both sides. And coming up with the decimal form, we could just go ahead and put that in our calculator. So -3 plus the square root of 2 is -1.6. -3 minus the square root of 2 is -4.4. All right, so we'll put that on our graph and finish the graph sketch. And that should, and then we got to determine some other information. So let's just go ahead and put our information for part A on our graph paper. All right, so y-intercept of 7. So that means I've got another matching point the same distance away from the AOS. And I'm going to say, 5 points on these for a parabola, so we could do another input. Okay, so we will do, let's just say input -2 to generate another point. So if I let x be -2, -2 plus 3 is 1. 1 squared is still 1. 1 minus 2 is -1. So -2, -1, and its corresponding point on the other side of the AOS are on the graph. And so this will be our sketch. And at this point, I would just double check and make sure that your numbers that you came up with for x-intercepts actually look reasonable. I should be crossing at about -1.5, and this is a rough sketch, but that's reasonable to think that that could be -1.5, and then about -4.5 would be the other one, and that looks reasonable as well. So that looks good. It's just a verification that you've actually sketched the graph correctly. And let's see, what else do we need to come up with? Domain and range. So the domain is always going to be all real numbers for these parabolas. And the range is going to be, it starts at -2. And since it's going up, it would be -2 to positive infinity. And then finally, where the function is increasing and decreasing. So we'll start with increasing. So increasing would be on this side where you could think positive slope. And it's about the x coordinates of this vertex. So it will start increasing where x is -3. It's not increasing at -3, so don't bracket that. So from -3 to positive infinity, it will be increasing. And then for decreasing, it's going to be coming from the other side, from -infinity to -3. And that completes that problem. And so let's do the other one. So for number 3, it opens down. So this is all the A information. It's going to open down because it's negative. And we got to find the vertex. So you could change this to vertex form if you like. You could also do opposite of b over 2a to find the AOS, and then plug that number in to find the rest of the vertex. So I think I'll just do opposite of b over 2a. So that's the opposite of 6 over -4. So 6 over -4. So that's going to be positive 3 over 2, which is another way of saying 1.5. There's our AOS. And then we'll just plug that number back in to find the rest of the vertex. So going to my calculator, -2, and you could just put in 1.5 if you like, raised to the second, plus 6 times 1.5 plus 1. So that's 5.5 is the y coordinate of the vertex. So 1.5, 5.5 puts us about right there. Maybe change color. All right, and let's see what else is contained in the letter A. The vertex is here. The AOS we've already found. That's x equals 1.5. The y-intercept in standard form, that's easy to see. That's going to be 1. So we can go ahead and plot that. And its match. The x-intercepts, so we got to solve. -2x squared plus 6x plus 1 equals 0. And when we solve this, we'll know where the x-intercepts are. So we want to use the quadratic formula. You could complete the square. This one doesn't factor, but those other two methods are fine. So the opposite of b plus minus the square root of b squared minus 4 times -2 is -8 times 1, all over 2 times a, which is -4. So I'm just going to go ahead and come up with those decimals in my calculator. So -6 plus the square root of 44. And then divide that by -4. I should have an x-intercept at about -0.16. And let's see, where are the other one? -6 minus the square root of 44 divided by -4. I should have one at 3.16. All right, so I'm going to go ahead and get my points 4 and 5. So I'm going to input 1 in, I won't write all this out and get kind of crowded, but I want to know where the point is on x equals 1. So I'm just going to replace both of these x's with 1 and see what comes out. So -2 times 1 squared plus 6 times 1 plus 1. And 5 is my output, so that makes these points. And now we're ready to go ahead and finish our graph. And check them out. Check out these x-intercepts. Looks like that's just a hair to the left of 0 on the x-axis. And that's just a little bit to the right of 3. So those look like they're good according to my graph. Let's see, so we found x and y intercepts. Let's do domain and range. So domain, of course, is going to be all reals. Range is going to be from negative infinity up to this y coordinate of the vertex, which was 5.5. And that should be bracketed. I think it was 5.5, wasn't it? Yep. And then I think the only thing left is increasing and decreasing. So this one is actually increasing from the left side from negative infinity to 1.5. And it's decreasing from 1.5 to positive infinity. All right, I think we got those. And for numbers 4 and 5, we're going to determine whether these have a maximum or minimum value and then find out what the value is. So the way you can tell right off the bat if you're going to have a maximum or minimum is identify how the parabola opens. So since the lead coefficient here is positive, the parabola has to open up. And the value, so that means we're going to have a minimum. And the value of the minimum is the y coordinate of this vertex. So you can do the opposite of b over 2a to find the x. That's the opposite of 8 over 2 times 4. The opposite of 8 over 8, which would be negative 1. If that's not the value we're looking for, we got to plug negative 1 in to the function. And the y value is what we're going to use to answer the actual value of the minimum. So negative 1 squared is 1, so that's 4 minus 8 plus 3. Negative 4 plus 3 is negative 1. So there's your complete answer for number 4. And then same thing for number 5, just that this time the parabola opens upside down, so we're going to have a maximum. And the value of the maximum, let's go ahead and find the vertex. So opposite of b over 2 times a. So that's going to be positive. 9 over 6 is 3 over 2, or 1.5. So to find the value, you're just going to plug 1.5 in for x. And the number that comes out will be our value. So negative 3 times 1.5 squared plus 9 times 1.5 plus 2, and that is 8.75. All right, and now we're solving quadratic inequalities using the graphing method. So for these, really for when you're solving these quadratic inequalities, just focus on plotting 3 points, all right? And I'll just go ahead and lay it out for you. You need the vertex, and you need the 2 x-intercepts, if they exist. And let's see what those x-intercepts are. You could find the vertex by doing opposite of b over 2a, and then plugging that number in. But when the lead coefficient of these functions is just 1, I think it's probably easier to change to vertex form. So I'm just going to be subtracting 4, and so there's the vertex form. And so that tells me that the vertex is at 2, negative 9. Let me go down just a little bit more. And then I need the x-intercepts, and in cases like this, when factoring, all you're really doing is solving the equation form of this, x squared minus 4x minus 5 equals 0. And when factoring is possible, I prefer that, because now we can see that the x-intercepts are going to be positive 5 and negative 1. And you could check out your AOS. It should be right in between. Should be the line that's right in the middle. Okay, so really, we just want a rough sketch because we're going to be able to look at our graph. And by the way, I made these x-intercepts solid because it says or equal to. When we come over here, when we find x-intercepts, they're going to be open circles, because those numbers actually aren't included, the ones that are on the x-axis. All right, so the way to interpret this is look at your graph, and the original problem would read like this. Where are the x coordinates on your graph? Okay, so we're looking for x coordinates, and there's a bunch. There's more than we could ever list. Where do they live on this graph such that they are above the x-axis? So where are the x coordinates that are above the x-axis on this graph? Well, obviously, they are on the x-axis, or they're on the graph above the x-axis where I'm shading. You don't have to shade, I'm just illustrating. So it would be all of these x's. All of these numbers, x coordinates on the red. And so where those are, and this graph, again, it's just going to keep on going to the left and going to the right as it goes up. So my answer is going to be all of the x's that are from negative infinity to negative 1. And we're going to include negative 1 because it says or equal to. And you can also see that the point is solid. And then we're going to combine that with this other interval of all the numbers from 5 to positive infinity. So greater than means where are the x coordinates that are above the x-axis, and then we'll do a less than where we're going to be looking for x coordinates that are below the x-axis. First thing we should do over here is set this up so that it is less than 0. So standard form. And now let's find our vertex. So vertex here, you could change this to vertex form if you like. I'm going to do opposite of b over 2a. So the opposite of b over 2 times a. And then I'm going to plug negative 5/4 back in for x. Positive 5/4 will be the x coordinate. And let's see what the y coordinate is. I got negative 6.125. So that's 1 1/4. And then down just a little bit more than 6. 1, 2, 3, 4, 5, 6, and just a little bit more. All right. And then, again, you just need the vertex and the 2 x-intercepts, which means you're really just thinking of what would the solution of the equation form of this be. And it looks like this one factors as well. That's always nice. The factors of negative 6x squared that add up to negative 5, so that would be negative 3 plus 1, 2x minus 6 plus 1, minus 3. That looks good. So we have x-intercepts at negative 1/2 and positive 3. And again, these are going to be open circles. All right, so we'll go ahead and sketch the graph. And now, because it says less than, we're going to identify, I'm just going to color the part of the graph that illustrates where it is below the x-axis. And these are where our x coordinates are that will answer this question. All the x-coordinates that are on the graph that are below the x-axis. And so we're really talking about this range of x-coordinates right here. And so this is going to be one of those in-between intervals. And we can't bracket because these are open circles. So we're going to be in between -1/2 and +3. And so that's our answer for number 7. And I think we just have one more. So the price and the quantity, price times quantity equals revenue. Just remember that. Price times quantity is revenue. So this is price. Here's quantity, X, and so we just need to multiply those together to get revenue. So the revenue function is really just going to be multiplying X times this P. All right, so that's going to give me -1/200 X squared plus 220X. So that's your answer for part A. Part B, what is the revenue if 40 units are sold? So we're just going to take our revenue function and we're going to replace X with 40, both of the X's, and then see what comes out. So I'm going to go to my calculator, and I came up with $8,792. All right, and then the next question is, what quantity X maximizes revenue? So this is just another way of saying, let's find the vertex, okay? So I'm going to do opposite of B over 2A again. And in this case, A is this -1/200 number, and B is 220. So the opposite of 220 over -1/200. So it's going to be a positive number. So I'm going to my calculator again. So dividing by 1/200 is the same thing as multiplying by 200. All right, so let's see what that comes out to be. So that's going to be 44,000. And that's the quantity that would maximize revenue, and then what is that revenue number? So now we're just going to take 44,000, go back up to our revenue function, and replace both of the X's with 44,000. And I apologize, I just realized I did a dumb thing. I just did A. I did not multiply by 2 times A. So I am sorry about that. I was using my calculator, getting a weird answer, and then I realized I did not multiply by 2 times A. So let me try that again. I'm going to find the quantity that maximizes revenue. All right, so going to our calculator now, okay, that looks a lot better. That should be 22,000. And now we're going to plug 22,000 back in for both of these X's, and that'll give us the maximum revenue number. All right, and so that gives us a number of 2,420,000. All right, that looks a lot better. And then we've got one more question to answer. What price should the company charge to maximize revenue? So we're going to take our quantity that we came up with that maximizes revenue, and we're going to plug that into this price function that we were given in the problem up above. So basically, we're taking the 22,000, that's the max quantity, and we're going to replace X with that number. All right, so plugging into our function. P is equal to -1/200 times 22,000 plus 220. and we'll go to our calculator. And the value, the price is going to be $110. All right, so that wraps up this video, and I hope that helps you for your semester exam. Let me know if you have any questions.